Perfect. Thanks so much. So for those of you that don't know me, Tasveer Singh, or Taz for short. At this point, I had some sort of lame joke set up to talk about Will Smith and enemy of the state and all that, but I'll bear you the misery and jump right to it. So for those of you that don't know me, as Natalie mentioned, I run Toronto.js. I advise you all to come out to our events. They're awesome. And I'm the CTO of a company called Hood Quotient. So part of my job is managing a team of developers. So basically, I'm responsible for ensuring that our developers consistently create high-quality applications. And I actually noticed that if you look at the roster for today, I'm the only talk that's listed as advanced. This isn't necessarily an advanced content talk, but it's more targeted at advanced developers or architects that are maybe in similar roles to myself and are looking at architecture at a more macro level instead of micro level implementation details. So that's what I'll be focusing on today, is macro level architectures. So as front-end developers, we're tasked with building front-end applications. We're given a problem, and we're told to solve it in the most simple way possible. However, the problem itself may not be so simple. And the reason for that is simplicity pleases. So in order to create a simple interface, it's a pleasing interface for the end user, but it's the underlying complexity that sells. And that underlying complexity gives us our jobs and it lets us go about our day. So how do we manage that underlying complexity in our problems? Put another way, how do we manage state? And for the purposes of this talk, I'll be talking about state as the thing that modifies the outcome of an action. Or to put it another way, both an input and a state determines an output. So to give that some context, I'd like to talk about types of state. So the most obvious one is data. So for example, you make a request to a server. You make the same request to the server, you get the same result. You make the same request to the server again, you get a different result. Some sort of state has changed, right? You're making the same input, you're getting a different result. Some sort of state has changed. UI. So if you have a list of items and you have a filter for that list of items, when you change that filter, the list changes. You're changing some sort of UI state, and you're changing the outcome of that state. Another example of UI state is when you scroll through a page. So as you scroll, you're updating the scroll state, which updates like the actual render of that page. So all of these things are state. Lastly, and the most frequently overlooked piece of state is your actual underlying code. Obviously, if you change your code, you're going to get a different result. So let's talk about these types of state when we're looking at different architectures. Now that we've established what these states are, I'll be focusing on how these states apply to an architecture used in a more idiomatic sense. I mean, obviously, you can build whatever you like using whatever else you like. You can build Google using like semantic whitespace for all I care. But I'll be focusing on the idiomatic use of these different architectures, the actual problem that they were meant to solve. So first of all, let's get started with the least involved approach, server-side rendering. So it's stateless, right? It's stateless on the front end. We don't have to care about state. All states managed by the server. That's great. You can simply refresh the page and you have the latest state. So you can achieve this by clicking on a link or typing in a form or hitting the refresh button. Everything's managed by the server. So I'll be using the example of Google image search to describe all these different types of state. And you can think of this as 3 different components. I'll be highlighting the interactivity between these 3 types of components. So here we have our search field at the very top. It's one component. We have some suggestions below that. That's another component. And then we have our results below that. Those are the 3 components I'll be talking about throughout this talk. So as we update our search component at the top, and let's say we want to look at trucks, in the context of server-side rendering, the entire page is now refreshed, just grabbed from the server. Like the actual trucks component is updated, our suggestions component is updated, our results component is also updated, right? Completely stateless on the front end, that's great. Now, if we want to search for SUVs, the same thing happens. We update our input field, suggestions are updated, and my results are also updated, right? Everything's handled by the server. So let's take a look at this in terms of complexity as we add more functionality. On the left-hand side, on the y-axis, we have complexity. And on the bottom, we have the amount of functionality you add. So in terms of server-side rendering, the more functionality you add, it's not going to get any more complex on the front end, right? So problem solved, guys. Thank you so much. I'll be leaving now. Just do that. No, I'm just kidding. So server-side rendering, while it's a great developer experience, it's a horrible user experience, right? It's not interactive or engaging in any way. There are slow load times due to full page refreshes, and you get that brief white page glimmer in between every time you do a full page refresh. So it's not very great, but it is a wonderful developer experience, and it's how things were done in the past. So how do we improve on that? Well, we can use a DOM or an Ajax library. And a few examples of this are like jQuery or MooTools or Prototype. And the way that this works is it basically helps you by managing your UI state. It does that using event listeners, so whenever you interact with your UI, you can listen to an event, and that will trigger whatever you want to do in terms of your UI state. You can render components of your UI on the server. So you're basically handing off the data state to the server and just handling your UI state on the client. And you can stitch those components together and the interactivity between those components on the client using one of these libraries. As I mentioned, data is managed on the server. Don't have to worry about that. So let's take a look at implementing Google Images with our DOM and Ajax library. So here, once again, I have those three components. I'll be using my image search field as one component. That's rendered via server. Suggestions is another component rendered via server. And my results is another component rendered via server. So when I type in trucks, everything's, so there's actually a binding on my trucks input field. That binding will then update the other two components appropriately. However, if I care about a pickup truck and I want to actually click on that suggestion, what happens? So I need to have a binding inside of that component that will then communicate back to the other components. So that when I click on pickup trucks, it updates the actual input field, the actual suggestions, and the results, right? So this intercommunication between components adds complexity. So if we take a look at our complexity chart, we can see that it starts off a little bit more complex than just using server-side rendering, but it steadily increases over time. So as we add more and more functionality, our application gets more and more complex, all the way up to 10 complexity, which is the most complex app. And once again, I just want to highlight that you can build whatever you want using these tools, but if you use them in the most idiomatic sense, it will increase complexity over time. So that's not very good. There must be a better way of doing this. So there is. There's observer-based frameworks. And examples of this are Backbone, Angular, or Ember. What these do is they manage your UI state, your data, and your code. So we can communicate to the server via JSON in order to manage our data. We can render all that in JavaScript in response to UI state. And our code lives in modules. So that's in stark contrast to if you're using jQuery or MooTools or something in a very idiomatic sense where maybe everything lives in one massive file and there's all spaghetti. The great part about using these frameworks is that they modularize your code and give them some sort of structure, so that managing your code or managing the live reloading of your code becomes significantly easier. But critically, you stitch components together using observers. So using our Google Images example once again, we have all of this is rendered via a client-side template in JavaScript. We have an observer listening to our input field, an observer listening to other types of UI interactions, such as our suggestions. So when we type in trucks, an observer event triggers, and we get our suggestions updating and our results updating. When I click on pickup trucks, we get the same sort of effect. The other two components will update accordingly and give us pickup trucks. So since our components are observing changes in the data as well as changes in the UI, I've created a larger diagram to sort of illustrate what's actually happening here. And this isn't the exact problem, but it's just an ongoing problem with MV, whatever type architectures. So what we have is we have our model layer that's then talking to our controller layer that's then talking to our views. But the problem happens is that when we start wiring our views to listen to other controller state and so on and so forth, things can get very messy at scale. Because critically, we're storing our data state and our UI state in different places. Our data state is stored in models, our UI state is stored in the controller. So the wiring can get very messy at scale. So if you take a look at our complexity graph once again, it starts out a bit more complex than DOM and Ajax libraries, but doesn't grow to be as complex as DOM and Ajax libraries as well. It's a bit more manageable because we have modules, we're managing all of our stuff, everything inside JavaScript. It's a bit easier to use. So this helps us with building front-end applications that are maybe less complex, but how do we manage front-end applications that are more complex? This is the Will Smith gif. And for this, I'm really going to talk about Rich Hickey. So Rich Hickey is the creator of Clojure. He gave a talk a little while ago at Strange Loop called Simplicity Made Easy. And he has said in that talk that what matters for simplicity is that there's no interleaving. In fact, the word complex itself comes from the word complect, which means to entwine, interweave, or braid. So this interweaving of components is what's creating this complexity at higher scale. As we add more functionality, things get wired and mismatched, and that's what creates more complexity as we add more functionality. He also goes on to say that simple means having one role, one task, one purpose. So how do we achieve that on the front end? Well, this is really quite new, and really it was Facebook that did a bit of research into this. They had implemented some sort of MVC type architecture when they were doing Facebook.com. And what they had noticed was it created just tons of complexity at scale. Things were getting wired all over the place. And one issue that they found was they had infinite UI loops. So when they triggered one event, something was listening to, or some sort of observer was listening to that, which would then trigger another event, which was listening to, and then you get some sort of infinite loop happening in their UI. And while I've never personally experienced that, that does not sound very nice at all. So what they did was they took a step back and really reevaluated how they're building their front-end JavaScript applications and came up with this pattern called Flux. So Flux, once again, manages your UI state, your data, and your code on the client. But critically, it separates your UI state from your data state. And I'll be getting into that a bit more later. Each component in the Flux architecture only is responsible for one thing. So to illustrate this, here's a diagram of the Flux architecture. They use React for their view layer, but everything else can be implemented using just JavaScript or whatever other language you choose. So here we can see that everything flows in one direction. We don't have wiring like linking state across our application. Everything is stored in its own place. Everything's responsible for one thing. So when a user initiates a web request to update data, that's getting reported back to an action. It's sent through the dispatcher. Our state itself is in a store. Whenever a store is updated, it triggers the view to re-render. And then whenever someone interacts with the view, any sort of UI, it once again triggers an action that goes back through this loop. So we don't have wiring linking things all over the place. So to illustrate that once again with our example, when we update our search query, that will trigger an action to be created. That action will go out and grab some data over the web, dispatch a new event, that will store new data and update the views accordingly. So instead of wiring things, back to the controllers as we did with MVC, everything is coming from one direction. We get our trucks. Once again, when we click on pickup truck, the same thing happens, right? Creating a new user interaction, creates a new action, goes grabs something over the web, reports back to the dispatcher, changes the stores, and updates our views. It's the same interaction. It's the same flow of data. We get pickup trucks. So to put this in a complexity chart, it starts out as more complex than every other solution we've looked at, but it doesn't grow to be much more than that. Everything's very predictable. Every component in our application is responsible for one thing. And in practice, we've actually been using this at Hood Quotient for a little while now. And in practice, I actually found it to be quite helpful for helping our development team predict what's going to happen. Everything is just flowing in one direction. It's very easy to test, for example, because we don't have state that is then changing the outcome of something. All the state is stored in one area, and we can easily test how that state change gets flowed onto our view and then back through the entire loop. However, I did find some things a bit more complex, and that is what makes this approach more complex than the other two. An example is error handling, right? So we have a view that triggers a user interaction, creates an action. What if there's an error there? We now have to store our errors in a store. We can't just store it in a controller. So I found that a bit difficult in order to wrap my head around when I was first doing this. What happens if we do an asynchronous UI update, right? We have to go through this entire loop a few times in order to just do an asynchronous UI update. So it starts out more complex, but it doesn't grow much more complex than that. And a few people are using similar architectures to do cool things like this. Unfortunately, I don't have much audio, but I'll talk to it instead. What's going on here is what CircleCI has done is they're using React and another library called Ohm. And since their state is separate from their view logic, what they're able to do is serialize their state in the left-hand window. So they're typing in something into the search field there. And since that state is separate from their view logic, they're able to serialize that state. And down in the console here, they have that serialized state. It's created into a string. It's much better with sound. So it's created into a string, and then they can go into another window, press some magic key that they've done, paste in that serialized state, and they get the exact same view on the other side. Right? So that's only really possible because they've separated all of their state related to their application, the data, the UI, as well as the code, from the actual running of the application itself. Another example of this is Jack Shadler has created this app called Goya. Oh, here it is. And what he's done here is used a similar set of tools in order to create this UI. So what he's done here is created this drawing app. It's sort of like MS Paint. And I'm just going to draw on here. So let's give him, he's thinking of stuff. And let's say he now has a yellow vest. So the really cool part about this that I want to illustrate is, once again, since they have separated their state from their view layer, what they're able to do very easily was implement undo and redo. So if you take a look at this history panel here, we can see an undo button, and we can simply just undo all those separate actions, or redo them, or do something else entirely, right? Make it a yellow background instead. But very easy to do because they've separated that entire UI state from the view layer itself. And he's actually done this in about, I think, 10 lines of code. So you can imagine doing that in maybe frameworks that you're more familiar with, maybe like Angular or Ember or Backbone. That would not be 10 lines of code in those frameworks. It would be much more involved. Here, he was able to do that in around 10 lines of code. I highly suggest checking out his GitHub repo. It's just, I'll post my notes later, and you can go take a look at that. So in closing, I just really want to highlight this slide and talk about the different types of architectures and where they're best fit. So you can see that we have the DOM and Ajax, and it's really best off for creating less complex applications. When you have an observer-based architecture, there's a really nice middle ground there that works out to be really nice. And if you have a one-way data flow, it really is suited best to the more complex applications you're going to create. And that's what I wanted to say. Thank you. Where's Natalie? Am I early? Yeah, sure. I'll accept questions. Yes. So the question was, with a one-way data flow, is there a risk that you would miss an event? Let me go back to my diagram just to better talk about this. No, because you'd actually be listening for all the events using your dispatcher. So in this context, using these particular tools, React will be listening to the events and initiating actions. Those actions would then get passed to a dispatcher. So unless you particularly didn't listen to an event, it would be difficult to miss one. Yep. When are those callbacks getting evicted from the dispatcher? So would you mind giving me an example? So like when you, like in the example that I use, when you type in a search, for example? When you're registered to listen to an event that isn't on the page anymore. Well, in this particular architecture, what happens is that all of the stores are listening to dispatcher events at all times. So whenever you create a new action that gets dispatched through the system, every store is always listening to it. So there isn't really potential for memory leak there. It is slightly more memory intensive than using an observer-based framework. But there isn't really a memory leak there, just in the way that it's architected.
I find these abstract box and arrow diagrams kind of hard to follow, so forgive me if we get into nitty-gritty implementation details.
No problem.
One way I've seen Flux implemented, I don't know a lot about it, but one article I read was basically that the nitty-gritty of it is that when you send events from the browser, you're sending HTTP head requests, and things that you're getting back from the server come over WebSockets. Is that a standard way of doing Flux? Has that kind of thing really been solidified, or is it really something that?
Yep, so I'm going to repeat your question, because I know Matthew would like me to repeat questions. Excuse me if I mangle it a bit in my repetition. But the question essentially was, in terms of specific implementations of Flux, he's noticed that like the actual requests are sent to a server via a HTTP request and responded via WebSocket. And so I just want to address that Flux is more of a pattern than it is a specific type of framework. It's just a way to model applications. But people do that because this type of application architecture lends itself well to data being received and going through the application in one way. So it's possible to create a web request and then listen via basically the rest of that loop, if you see what I mean. So it's not like you're creating it's not like you're creating it's not like you're clicking on something in a UI, and then like if you're using some sort of MVC type architecture and you click on something in a UI, that response has to be to that same observer callback in a way. You know what I mean? But with this, since we're creating an action that gets sent back to the web, that web will respond through a dispatcher. It doesn't really matter if it's the same specific action that we're responding to or if it's a different one. So yeah, in terms of specifics, like I've seen it modeled in a few different ways. I've seen people model UI actions as one type of action, and then server-side actions as another type of action. But critically, they're still flowing through the dispatcher and the stores in one way. And just to illustrate and to give some context into why Facebook did this, what they were noticing was actually a zombie notification. So in their chat application, let's say I send you a message, and you respond back, it's going to show up with like a one unread message count in my UI. But what they noticed with like an MVC type architecture was they were getting zombie unread message counts. So I'd go and click on that, but I wouldn't have an unread message, and then it would go away. But then I'd go back and click on it, and you know it would just be really annoying that it would say that there's an unread message, but there wasn't one. So in that context, you have an HTTP request and a server-side event that need to basically do the same set of actions, and that is why they that's basically why they created Flux and why they're building their UIs in this way now. Does that answer your question? Yeah. Okay, great. Well, thanks so much, guys. I'll be here, so feel free to ask me questions at lunch or later. Thank you very much.